Okay, so this is an overview of our Houdini World of Warcraft import pipeline. All the tools are custom made in Python, and they all do rely on WoW exports metadata, so JSON files, CSV files that are exported out of that. We'll go through it one by one, I suppose. We'll take a look at the switches here. So this is the main one, the ADT tile import, which is the terrain tile. There's various switches here that allows you to not import doodads or not import WMOs or skip WMO doodads. We'll turn all this stuff on. Quick tile is just debugging. It just prevents the script from generating the materials for the terrain tile. Debug is just more verbose information in the output log and also doesn't perform some cleanup steps, so we'll leave some helper nodes around so I can investigate those. Legion terrain, so somewhere around Mists of Pandaria, I believe, Blizzard actually changed the way that they do terrain. It used to be very simple, just, alpha map, mask the materials or mask the textures, boom, done. But now they have different height textures, and specular textures, and there's different blending operations, and it's a lot more complicated. Skip vertex color, so I think around Warlords of Draenor, they introduced vertex coloring onto the terrain tiles. And this just allows some color variation along the tile. So it's the same repeated texture, but there'll be differences in brightness in certain areas, and that's due to the vertex coloring. Force vertex color update. So the script will automatically write vertex colors the very first time it generates a tile. But if that tile already exists, it will have a saved bgo.sc, Houdini's native file format, saved already. So it'll just load that rather than doing the vertex coloring, because it does take a little bit of time to do that. USD tests, that was just me testing USD. Nothing really came of that so far. Version 2. So version 1 was the first iteration of the script, and it had a lot of problems. I didn't really have a way of not generating doodads and still generating WMOs. Every system worked off of the previous system. So first it would do the ADT tile, then it would do the doodads, then it would do the WMOs, then the WMO doodads. I didn't have a way of individually calling each of those functions because every function required information from the previous function. So version 2 just has all those systems decoupled and just makes working with it a lot easier. Proxy export, that's for more distant terrain. So this will load up each tile with the doodads, WMOs, all that jazz, and then save it out as a HIP file to be edited later if needed, and also exports it as a Redshift proxy. This is meant for distant terrain, so the proxies are very efficient at that. So let's go ahead and run this. If we go to WoW export and we go find our troll raid, which is the Broken Isles, and we find a terrain tile that we want to export. I've been doing a lot of stuff in High Mountain, so there should be some nice tiles there we can work with. So let's grab, let's say this one here, 22, 23. So let's go grab that. 22, 23. Load that in. So the first thing it does, it starts generating those tiles. This creates all the materials. It does take a bit for each tile because it's using a custom OSL node in order to, connect all the textures and everything. So it's doing the doodad import. Looks like there's 330 unique doodads. It will only ever generate the unique doodads that are needed and then instance the rest. And then it exports everything as a BGO, kind of smashes everything together and then exports it like that. Now it's doing the WMOs plus all the WMO doodads. Okay. You can see it going through each WMO here. There we go. So that tile is now complete. And if we look here, there it is. Turn off the grid. So we've got some, I think this is the Hunter Lounge, or Hunter Order Hall. Yeah, I think that's what this is. Cool. So it looks a little funny, but that's just because it's packed geometry, and sometimes Houdini is weird with displaying materials on packed geometry, so it's kind of two different shades of colors. But anyway, so it creates one node here, the ADT OBJs. There is a control here for viewport display that just lets you set it to, you know, bounding box or anything. It doesn't propagate to the Doodads or WMOs, though. I never implemented that, but that is something I do want to do eventually. So if we take a look into here, we have the tile, we have the Doodads, and the WMOs. We also have these Python scripts, which is just a big series of numbers. This is the unique model enforcement. So what this is for is whenever you're generating multiple tiles, because you can select as many tiles as you want with these scripts. So let's say you generate, you know, 4 tiles, all here. They all touch each other on the border here. So this, let's take this little tree, for example. This tree might exist in 2 different tiles. So what this script does is it takes that variant, or the file data ID for that specific item. It takes its position, rotation, and scale and combines that into a single unique number, and that's its unique identifier. So if it generates tile 1, creates a unique identifier for this object, and then goes to create tile 2, and the same math generates that same number, it will know not to create a doodad here. That way you don't have duplicates across border tiles. Same goes for WMOs, just does the same thing. So let's look at the tile itself. And I just unconnected it. Whoops. So the tile, we're loading a bgo.sc. You can see that it does have a color 3-float vector attribute. That's the vertex coloring. If I just uncheck this, we can visualize that color. And it should be between 0 and 1, I believe. Let's go infrared. So this is the vertex coloring data that is generated. So areas that are, you know, more to the red spectrum have a higher darkening, I suppose, whereas areas that are brighter will have less. And I can show you the difference between that, I suppose. So we feed in the materials. There's 256 materials because there's 256 tiles. If I just kind of switch through this, you'll see that weird material behavior. After that, we promote the UVs from point attribute to a vertex attribute, and then fuse all the vertices so that there's no seams between each group. And then we pack the geometry and then just give it a color. I just color it the same as the node color. That way it's a bit visually easier to see which is which. So if we hide the doodads and the WMOs, and I'm just going to create a redshift dome lights, and we'll make a camera here. And we'll take a look at this tile and see what it looks like. I'll just hide these. Go back here. Lock the camera. And let's see what this looks like rendered. It takes a second to start up. There we go. So here's our ADT tile. It looks a little strange here, but that's because that big building goes there and kind of alters that. But let's take this cliffside, for example. Looks quite nice. Let me actually just do a production render, just so it doesn't keep updating on me. And we'll compare the difference between this render and one without the vertex colors, just so that you guys can kind of see the difference that makes. Like I can see here that it's darker. I think that's included in the vertex colors. I'll also put the quality settings for our rendering down a little bit, just because, well, we don't need it to be that high. Take a screenshot of that. And let's go delete those vertex colors. So the attribute is a point attribute called color. That's now deleted. So if we re-render this, it should look very dark. Let's see here. Oh, right. We can't delete that attribute. We need to keep it. But what we can do is just set it to the default gray value. So I'll put a point wrangle here. And we'll say v@color equals 0.5, 0.5, 0.5. So that's the default gray. That should be overriding that value now. Okay. Now we render. There we go. So if you notice, it looks a lot flatter than it previously did. If we look at the two side by side. So you can definitely see, not a very nice comparison there, but there we go. You can definitely see that the vertex color data definitely makes it kind of pop out a lot more. So very nice to have that information. I think it makes quite a big difference. Okay, so we'll remove that change that I made. And since we were in there, let's take a look at what the materials actually look like. So there's 256 terrain blocks in a tile, and there's 256 materials. So if we pick any one of these materials, we can see that there's a whole bunch of stuff in there. So I've got the original alpha map here, the 4 different layers, splitting out their alpha, the height versions of those layers, because these are the specular versions, the original ones, and splitting out their height data. This is the custom OSL node that I was talking about. It's got tons of different information like, height scales and different values here, vertex color data. This took quite a while to figure out how to make, but pretty pleased with it. But yeah, so it creates 256 materials and figures out what's needed for each tile. So that's pretty good. And if we take a look at the, if we take a look at the doodads here, just show those. So doodads is things like, trees, rocks, any little thing is considered a doodad. And if we take a look at their materials and whatnot, so it'll only generate one material per unique object, so there'll never be duplicates in here. Everything is instanced as much as possible to make it as efficient as possible. And if we look into the doodads subnetwork, we have this one bgo.sc, which is combined doodads. So this is all the different doodads just kind of smashed to the world origin, and then it will instance, using a copy to points, all the different objects that it needs to. And if we take a look at these objects and look at their attributes, so each one is a packed primitive, packed geometry. So each object is represented as a single point. Now, if I needed to modify these in any way, I can just split it and then unpack it and do what I need, and then repack it and combine it in here. But each point has a model name attribute, which is obviously the model name, and then the unique variant attribute, which is typically the file data ID, I believe. I also have this on the primitives as well, just for ease of selecting objects and then, deleting primitives based on model name, for example. That makes things a lot easier there. I also preemptively drop a blast node just to kill anything that's, has effects in the name of it. So if I just invert that, that's like these flat planes. Like this is a bonfire glow thing. I don't need those. I'll never use them. So I automatically delete them, and I keep the node here in case I ever need to retrieve it. So like I said, copy to points node, and it'll instance everything onto the terrain in the exact position, rotation, and scale that it should be. And that's all determined by these points here. So we have a point cloud, and then every object gets instanced onto that. And this points generation subnet is very simple. I just have 4 different wrangles. If there's more than, I think, 3,000 points or 2,500 points, it switches over. There is a breaking threshold for this script. If it's more than like 10,000 doodads, I think, it'll break. I don't remember the exact number, but it can go pretty high. But some places like cities, like Kultiris, for example, they'll have many thousands of doodads. But if we take a look at the code that this generates, you can see it adds a point. It sets a point attribute called variant. It sets the point's position, which is a vector value. It sets the point's p-scale, and then the orientation. So for orientation, that's a little different. I use quaternions for everything, even though doodads on ADT tiles use only 3 values for rotation. They're not technically a quaternion, but I just find that Houdini handles it better later if I need to edit it for whatever reason. So pretty straightforward. It just generates a bunch of points, puts attributes on them, and, away we go. It generates the doodads onto it, copy to points, and yeah, pretty straightforward. Let's take a look at the WMOs here. So WMOs, we have the materials and the doodad materials. Once again, it only generates unique objects, so there'll never be any duplicates in here. Same thing with the doodads as well. The WMOs are just a bunch of packed geometries all smashed to the origin and then instanced onto the points later. And they have the same attributes as the doodads have. Model name, variant, for example. Now, variant is a little strange here. There's an underscore value, and that's because WMOs have different sets. So this is set 2, for example. So it has the suffix of underscore 2. Set 1, set 1. I ran into that issue, and it tripped me up a little bit. Points generation, the exact same thing. This can handle up to about 2,500, 3,000 points before Houdini just crashes. It's not a limitation of Houdini, it's a limitation of how many lines of vex you can have in one attribute wrangle. That's why the doodads have 4. But typically I've never seen more than, I think 200 would be the most WMOs you would ever see on a given tile. So just having the 1 is usually fine. Now, because these are all packed geometries, we can go take one, for example, like this house here. So if I select this, and we want to make sure we are selecting by primitive attribute. Actually, let me just grab it from here. Let's see, where is that nice little house? Right there. So let's select by... Oh, it's already being selected by model name here. Whoops, that's not selected by model name. Sometimes the selection tools in Houdini are a little weird. But this should have... Oh, right. I never did implement that. This was supposed to be attribute promoted up to primitives as well, just because it's easier to select that, but I guess I never did that, so I'm going to have to add that. But we can select by point, attribute, model name, and single that out. So we have this artifact hub hunter set 1, and we can unpack that. And you'll see now there's 385 pack geometries. So one of those pack geometries is the actual house itself. So I'll put an edit node and just move that aside. So that's one packed primitive here. But each one of these objects is its own packed primitive as well. So if I take a look at model name, you can see this is hunter, crocohide, etc. And like I said, these are all packed geometry. So for whatever reason, if I need to edit these, like this little chair, for example, I guess that's a set of 2. But if I ever need to edit these, I can always just kind of blast out one of them and then unpack that. So we're 2 levels of unpacking now. But now it's the actual polygons and vertices and whatnot that I can edit. There you go. So that's pretty cool. What else can the script do? Well, a bunch of other stuff, to be honest. I can generate WMO hero objects, so that's individual WMO objects, similar to how it's constructed here, just, you know, individual WMOs, and that has the switch for if you want doodads or not. Doodad import, that's another hero object, just imports one doodad. Text up gen, basically what that does is you select, you know, some doodads or whatever. Text up gen. So it says text up gen complete, 243 textures found. Please run the text up specific PowerShell script, then run the texture upres change script. So I made a PowerShell script called text up specific. So this Python script basically just exports a list of texture names that need to be upres, and then they'll go in a mirror directory just with upres instead of original. So if we look at the textures here, you see it's wowlib, that's our working directory, textures world expansion 3, doodads, blah, blah, blah. It would just go into a similar file structure, just upres would be the difference here. And then text up change just, you know, modifies all of these to be the upres texture path. RS mat parms, that's if I want to change a bunch of material properties all at once. That was for more, you know, advanced things like color space, MIP bias, bicubic filtering, filter type, etc. There's a weird issue with the current version of Redshift where if you have a texture that has the color space utility sRGB texture, if you have minification set here, then it gets very dark whenever you zoom out, and the closer you get, it gets brighter. So I found that these settings prevent that from happening. Not sure why it happens, but who knows. RS proxy export, it just takes the current tile and exports it as a proxy. RS proxy import does basically the same thing, just allows you to import proxies. So if I go to RS original, or where the hell did I put that? Upres? Geo original maps control rate. Don't remember where I actually put that. Original maps control rate. Let me find that for us real quick. Maps. Interesting. Well, that seems like a bug. They all went into Azeroth. Well, another thing to fix, I suppose. Let me open up a scene and show an example of this. Okay, so this is an actual production scene with a few things deleted just to not give too much away. But very similar setup. So we have the ADT OBJs. So there's two different tiles in here. And this is what I meant by the color coordination. So you have this pink tile here, and then this, gray tile here. The gray tile, we deleted all the WMOs because we're not going to be using them, but everything else is your standard setup, just as it was in the demonstration previously. The only difference here is that we have proxies for the greater terrain. I also imported a hero OBJ, which was some fence posts, it looks like. Yes, fences. So that was for something related to the scene. We also have this ground garnish here, which I think is actually called ground effect doodads, but I always just call it ground garnish. It's just that little thing you sprinkle on top. Let's check out these proxies. If I make it visible, nothing happens. That's because I have this viewport display thing here. It can get pretty heavy because there's a lot of geometry to display. So if I set it to 2, which is mesh display, you'll see Houdini's going to hold here for a bit while it generates all this geometry. There's quite a lot in there. I don't recall how many tiles there are in total, but there's a lot. So we'll hang here for a second while it just generates all that preview geometry. There we go. We can see it doing that now. So there's a lot of proxies here. That's why we keep it hidden, because you don't really need to see it. This is just meant for distant objects here. So this is High Mountain. All of these are Redshift proxies, so they're not interactable or editable in any way. So like these flat plains up here, that's most likely like a snowdrift texture effect or something to that avail. So in order to edit this, we'd need to open up the original HIP file. So if I go to open HIP environment, here's all the different tiles that are used so far for this project. So I'd open up the original, edit it, re-export it as a proxy, and then it would update in this scene. I think this is, I forget what the zone is called, but this is like the Hall of Valor, I think? I don't know. Anyway, tons of terrain here. If I were to count how much terrain is there, if I do OBJ, ADT, proxies, a lot of stuff in there. What is the length of this array? 422. So there's 422 proxies. Now that doesn't mean there's 422 tiles, because if we look in here, a lot of proxies. But it's the same setup where you have the ADT tile, the doodads, and the WMOs. So these three proxies comprise one full tile. The WMOs don't have any doodads in them. I just thought it was unnecessary. I mean, if there's a building far off in the distance, are you really going to notice if there's like a book sitting on a table on the inside of it? Don't think so. But using this method, we're able to have, tons of distant geometry in our scenes. I have a video that I rendered out. So that's the, scope of the tiles. So it's quite a large zone. I mean, I'm not sure the exact size of it. I think it's something like 52 square kilometers of tile, but it's pretty vast. It's the biggest we've ever done. You can see there's still like effects crap left over. I don't think those are called effects something. I think they're called like cloud or mist or whatever. But yeah, we'd need to go in and kill those two. Set that back to 0. Don't need to show that anymore. The last thing that would be interesting to show is the ground garnish generation. So basically we have a script that looks at every unique texture in a tile, and it will see if that unique texture has, it'll find the ground effect ID for that texture, and then go see if there's any ground effect doodads that coincide with that ID. If there is not, then it will just skip it and won't bother baking a mask for it because there's no doodads anyway. But if there is, it will render out an 8K map in order to scatter things on. It will also find, the different proxies that it needs. So this is not a completed system yet, but it's in progress. So this is one of them. So this is the 7HM dirt for tile 2222. And this is the mask that it generates. So this is where we can scatter, whatever little rocks and pebbles and this and that. I think this is a hole here because there's a cave here. But if we look at the ground garnish proxies, these are all the redshift proxies that represent that geometry. Just little, ground things. And then what we do to scatter them is we have individual instance objects for that. So we have these points here. So like let's say dry grass, for example, just at the base of the mountains. So what it does is it grabs a clean version of the terrain that has a different set of UVs. It'll add normals to it just for orientation purposes, attribute from map, and ramp, scatter, some other stuff. And it'll also just generate 4 points. And these 4 points just have a few attributes on them. Well, one actually, just an instance. So this specific texture, drygrass01 underscore 1024 underscore S, only has 4 different ground garnishes. Grass 01, 01 again, 2, and 2. So that's not an error from the script. That's actually what's in the database, so sure. Each tile itself also has a density multiplier. So this one has a density multiplier of +10. Other textures might have lower density multipliers. But if we do the render ground garnish, and I just hide the regular textures, point over there, not sure why, I'll have to figure that out later. But I do have some top level controls here. So a scatter density, so we can increase how many points are scattered. Works pretty well. I also have a scatter sensitivity, just a color cutoff value. So if the pixel value is 0.2, 0.2, 0.2, then I can cut it off just so that there's less random points everywhere. And this is also the same for the second tile. I also have a similar setup. It's not done though, so I don't have like the nicest naming convention for this. I want to, change this a bit so it's not just 1, 0, and 1. But haven't gotten around to doing that yet. And well, I think that about covers most of what there is to show. We can do a render somewhere. Let's grab a new camera. Just put it here, for example. And we'll delete the redshift ROPs because we had a bunch of custom stuff set up on that and a light dome. And let's just take a look at what this looks like. Now, for full production renders, whenever we do have the proxies all enabled, it does take quite a bit of time for pre-processing before it'll actually render out an image. So I'm just going to pause the recording here. All right, so this is rendering now. We found a cool little spot. So yeah, you can see it just adds that bit of clutter around on certain textures. Now, it's not perfect. It's just done recently, so there are still issues with it, I'm sure, but that will be ironed out as things go along. But as you can see, it does add quite a lot to the scene, little pine cones or whatever, little rocks, things like that. So it does add quite a lot for basically nothing. I mean, it doesn't take terribly long to generate this data. And I mean, for certain areas like down here, for example, there's just tons of ground clutter. This might actually be set too high, but I can always take the scatter density down as needed. Just like in game, if you turn down your graphics setting, it turns down how much stuff is actually scattered. But you can see it does generate quite a nice result, a nice full looking in-game tile. One more thing I forgot to mention is each one of the different doodads for the terrain ground garnish does have a different weight. So like maybe this pebble will show up more often than this twig. That is also taken into account here. So that's all built in. But yeah, pretty happy with the system. It is an ongoing thing where it will be, iterated on and upgraded and things added to it. The only other system that I haven't implemented yet is the game object import. So a game object is anything that a player can interact with. This can be anything from signs to campfires, chairs, anything you can click on as a player is considered a game option. That's going to be a tricky one because it's not something that WoW Export can actually export data about because that's not kept on the client side. That's all server side. So if I did want to export that stuff, it'd be more tricky because I would need things like a packet sniffer. And that is technically going against TOS. So there's always that risk there. So might not do it. It's looking unlikely, but we'll see where things go. But anyway, so hope this was informative and maybe gave you guys some ideas about, your own type of systems you can implement. We used to be doing everything in Maya, but we have switched over to Houdini, and I couldn't be more happy with it. It's a very versatile program, and if you know a bit of coding and you can really unlock a lot of its potential, it's fantastic. Anyway, thanks for watching. Have a good one.